type of question where you're going to try to find or identify what the actual equation would be for the rational function based on what the graph looks like. Okay, so when you're looking at your graph, you're going to identify several things. Okay, so I'm going to include the x-intercept. Okay, so you can see here the x-intercept is going to represent the factor of your numerator. Okay, so when you're looking at this problem right here, you see that this is a minus 7. That corresponds to a factor of x minus a minus 7. So you get x minus or x plus 7 as your numerator factor, right? And so that's the first step. You can use your x-intercept to find the factor in your numerator. And then to find your denominators, what you're going to use is the vertical asymptotes. Those are going to be the factors in your denominator. So the factor that corresponds to this vertical asymptote here is x minus a negative 6, so x plus 6. And here you get x minus 7. Right. The final thing that you're going to do to determine what this function looks like is you're going to either decide, does it fit the pattern of 1 over x or 1 over x squared. Now think about what 1 over x looks like. 1 over x looks like this. 1 over x squared looks like this. Okay, so notice when both sides approach the asymptote in the same direction, you're looking at a multiplicity 2. When they intersect or they approach it in opposite directions, so here from the positive side it goes up, from the negative side it goes down, then your multiplicity is 1. Okay, so when you look at this, at the x, at this asymptote, they're both going up in the same spot, so that indicates what power? Yeah, a square, right? It models this behavior, the reciprocal squared. Okay, what about at the vertical asymptote 7? This is going to model also squared. So this would be your function for the first problem. Okay, let's look at this second example. Okay, in the second example, my intercept is at negative 2, so I'm going to have x minus a negative 2. There's my numerator. And then my denominator is going to be the factors of my, or the factors illustrated by my vertical asymptotes. So x minus a negative 1 and x minus 3. Okay, and now when I look at each of those, so here at the minus 1, I see that my asymptotes are approached up from the negative side, down from the positive side. So is that considered a power of 1 or 2? 1. They're opposites. Okay, and then here from at the factor x minus 3 that corresponds to this vertical asymptote, again from the negative direction it goes down, from the positive direction goes up. They're opposites of each other, so that indicates a power of 1. And so those would be your factors. Okay, I want you to try really quickly this last one. Okay, if you can see it. Okay, so when you look at this example here, we have a minus 4. That gives us our factor of x minus a minus 4, so x plus 4 in the numerator. And then we have a factor of x plus 3 illustrated by this first asymptote and x minus 4 by the second asymptote. And then when you look, so here my graph goes down from the negative and up from the positive, so that's a 1. I leave it as it is. And here it goes up from the negative, up from the positive, so it's approaching it the same, so that's a 2. And that would give me my factors.